All right, great. I can still see your faces too, which is exciting. I know there's still going to be some people joining, so so welcome everybody. We're so glad you could make it to our Green Chemistry Connection session. This is just an opportunity to connect with some like-minded colleagues and, share some resources, share your, pretty much share anything. And, we've got a great lineup today. We're going to have a couple short talks and some breakout rooms and that sort of thing. So if you joined us last night, you kind of got the lay of the land here for this. But it's really an open discussion, and we really are happy that you're able to join. So I'm just going to introduce briefly, if I can get to the next. There we go. Technology's working for us today. Just a brief welcome here by myself. I'm the Executive Director, Amy Cannon of Benign, and happy to have Natalie O'Neill here, who you're going to hear from in a moment, and Janie Butler, who's also here waving, and you're going to hear from Janie today too. And I think in the background we might have a slide, I'm not sure, but we have our Juliana Vidal here, our communications intern as well, our fabulous communications intern. So we're really happy to have you here joining us. Today's agenda is similar to the last one, but basically we'll do some really brief welcome and updates. We hope you brought your own resource or request. Again, if you didn't and you just want to chat and hear about what other folks are up to, then you're more than welcome to do that as well. But we'll do a bring your own resource and request session shortly. And then we've got two fabulous talks, and I'm going to leave that to Natalie to introduce Felicia and Ed, who many of you might already know and know well, so that's great. And then we'll do some breakout room discussions in the second half of this too, that you can shout out really which, you can tell us which of the breakout rooms you want to join so that you can talk a little bit more about any of these topics. And I know Janie's also on this too, right? So we've also got Janie talking a little bit as well. So just to talk a little bit about what we talked at the last session in August, I gave a really brief overview of kind of the different benefits of these social networks. And there's so many different benefits in these social networks when you're trying to catalyze change and to bring a new idea or technology to adoption. And all of these different benefits, when applied to education reform, which is pretty much what we're talking about in green chemistry education, there's so many of them, right? So really tapping into that expertise, developing future leaders, really this, social capital, leaning into that social capital so that when you do want to create change or take action, that you've got that extensive network of like-minded colleagues that you can tap into. So we're hoping we can do a small part in helping to build and facilitate these sort of social networks. This is what we talked a little bit about last time. But building off of that, what we're looking to do, and what we're really looking to do throughout this is to build out a community of practice. And really, I would argue that our green chemistry education community has been functioning as a community of practice for a number of years. Maybe it's not formally been presented as such, but if you look at the definition of a community of practice, it's a group of people who share a concern or a passion for something they do and learn how to do it better as they interact regularly. So I'd say we're a community of practice. I'd say we do share a concern or a passion. I think it's, if you're showing up to these, you probably have bought into the idea of green chemistry as an essential piece to the chemist training. And there's so much benefits in terms of sharing what you do and how you do it and learning how to do these things together as a community rather than in isolation. So we see all kinds of wonderful benefits in these community of practice. We, in order to function as a community of practice, we have these three things in common. We have a common ground and purpose and values. I feel that we share that. We have a community, which is all of you joining on a regular basis. And that's that set of individuals connected. And then practice, and that's what we're hoping that we can share here in these sessions is, sharing your ideas, sharing your frameworks, your tools, your curriculum, your resources, all of these all the wonderful things that you do in your own practice. And sharing that with this community is so vital, because really what we're looking, as we're, again, I think this community has been functioning this way through our both informal and formal platforms by interacting regularly in conferences, by organizing symposia together. I mean, we've all been working together for a number of years. And if you're new to this, welcome, and we're bringing you right into this, and you'll be right alongside us, working along for the next symposia once we can meet in person. But for now, we're going to be, trying to do much of these virtual meetings as we can, and that our time allows. Because what we're looking at really is taking this community of practice and shifting it to a community of transformation. And because we would really like to see some deep, meaningful change in chemistry education. And we think we're going to get there with all of you. So a really brief recap from last time. We had Doug Rainey and Julian Silverman, our two faculty fellows that are working with us on our Toxicology for Chemists program. And they shared some of the frameworks of their work that they'll be doing to include some of our brand new modules that are coming out this fall and likely rolled out to the community next year, 2021. So if it's something that you're interested in, if you've, say, yeah, I would like to see how I can include some of these concepts in my coursework, please reach out to us, and we'll be rolling these out over the next year and throughout 2021. You can also sign up for our newsletter and just make sure you click the box Toxicology for Chemists, and you'll get those email notifications too as some of these open access resources are made available. So with that, I think I'm going to hand it over to Natalie, because Natalie's leading this project. So.
Thank you, Amy. That was an amazing introduction, and I think just kind of like setting the stage for why we're all here today, and I'm so excited to see you guys. I think these are a great way to stay connected. So just kind of a nod back to what we talked about during the last one in the higher ed space for the resource guide. John gave a presentation about what he's doing at the University of Toronto, but then kind of gave also I'm working with Beyond Benign as a higher education fellow, and we're starting to kick things off. And so we would like that if you are interested in working with us on the Inorganic General Chemistry Guide, please feel free. You can let me know in the chat. You can reach out to me directly. If you have let me know already that you are interested, I've probably already reached out to you with some information and some survey, and also introducing John, and we hope to kick off this project in the next few months. So you can go to the next slide, Amy. Awesome. So what really has brought us together here today, and continues to through Beyond Benign, is the Green Chemistry Commitment. So just a nod to everyone, if you're a Green Chemistry Commitment signer, hello. If not, we welcome you into the Green Chemistry Commitment signing community, but also just here, and we'd be happy to talk to you more about that. There are 70 institutions globally signed on, many of them here today with representation. You'll hear from Ed Brush, who is one of our signers from Bridgewater State. And so just to highlight our Green Chemistry Commitment. And really the conversations we're having here are around these student learning objectives, so theory, toxicology, lab skills, and application. So that's what you can expect from the Green Chemistry Connections in terms of topics as it goes back and links into our Green Chemistry Commitment program. So we also do have, and we just released case studies that were done this year for 2020. They are listed on our website, but they are also in the shared Google folder that you all have access to, that was shared at the beginning of this event. We'll make sure we share it throughout the course of the day as well. But those are there if you're looking for examples of green chemistry in action in departments that may be similar to yours. So I highly recommend you check those out. And we have lots of opportunities. So Amy and I have already mentioned 1 or 2 in the Green Chemistry Commitment Program and beyond, right? Working with our toxicology work or with our inorganic general chemistry resource guide. But there are other opportunities as well within the Green Chemistry Commitment Program, which is tracking the progress, adding to a collaborative voice, professional development, networking. Pretty much you could say like green chemistry connections all the time if you're in this Green Chemistry Commitment Program. That's our goal, that's our hope, that's what we're building towards. So I think there's opportunity there. If you'd love to know more, please let us know. There's lots of commitment members here today that would be happy to talk more to you as well. And so I will just say that Irv Levy, who isn't here with us today because he's off teaching at Simmons College, but he is our senior faculty advisor for the Green Chemistry Commitment Advisory Board. We're starting to jumpstart this again, so if you're on the board, you've received an email, but Irv is working in this space to really get the advisory board right up to speed and back into action and really thinking about what is green chemistry 10 years from now, 20 years from now. Do we need to update the Green Chemistry Commitment as it was started in 2013, right? Do we need to adjust to the times that we see here? So there is that opportunity. If you're interested, please reach out to Irv, or again, you can say hi right into the chat and let us know that you're interested and we'll connect you with Irv. Awesome. So at this point, I do just want to do a short poll just to see where you are at. So I'm going to launch a poll, and it's about teaching chemistry, and if you're doing it remotely due to the pandemic. So please weigh in here before you guys head off into networking, just to see where you're all at. And then we'll talk about just virtual resources that we have available on the Beyond Benign website. And I think this poll will help us decide, are we adding to that list? Are we seeing more of a mix this semester? I see people weighing in now. I'll give you a few more seconds to vote.
Sorry, I don't know how to vote.
Oh, Felicia, you can't vote because you're on the inner circle of a co-host. I apologize. So we will take your vote. We'll take your vote into consideration, though.
Okay.
So it looks like everybody has stopped. So I'm going to end the poll now and show you what we've got. So it looks like 53% of you are online for the semester, 23 or 29% with in-person labs, all right, and then 47 a mix of a hybrid, and no in-person instruction. Wow, I'd love to know who the 6% is in this group. So it does look like these virtual resources may be helpful to you if you are teaching online. This is a rolling kind of, please send us if you're finding things that are useful for you in your courses, send them to us, we can add them to the list. I know Dean Campbell couldn't join us today, but he has been making amazing short YouTube videos and sending them to me, and I'm like, these are great, but I don't know what to do with them. They're going to be added to this virtual resource list, and so if you have things like that, we would be happy to post them and share them through this opportunity. All right, so I think, oh, that's a great one that just came into the chat. Jennifer Stockdale added in there, the students from the University of Toronto have a series of videos. Yes, they do, and that is on that list. Those are great everyday videos that explain the principles in everyday terms. So prevention of waste is looking at how you cook and prevent waste at the same time. They're very easy to digest, and so yes, anything like that that you know about, send our way, please. All right, so we're looking like we're on schedule, which is great. I've got you guys set up into breakout rooms on the back side today. I'm excited because our lovely Juliana Vidal is going to stay in the main room so that I can come and network with you. So you should be in a room with either Amy, Ed, who is a speaker for today, Ed Brush from Bridgewater State, Felicia Eckhorn from University or Virginia Tech, myself or Janie Butler from Beyond Benign will be in a room with you. Amy, if you want to go to the next slide, we'll just say The idea here is you don't necessarily have to bring a resource. Some people have already uploaded resources into the shared Google Drive, which is awesome. You can always add to that space after the fact as well. But this is really just to get to know each other. So keep it light, get to know each other. So your name, your affiliation, and then a request or a resource, or maybe you're plotting something in development and you're looking for somebody to do it with you. This is the time to find somebody out there to do it with you. All right, so I'm going to open up the rooms. You're going to have 15 minutes for networking, getting to know each other, and then we will come back together to hear from Juliana Vidal, a little bit about communications. So I will open the room and send you off. Hopefully it's gone into presentation mode. There we go. So I wasn't able to go into a breakout room this time. We're figuring out all of the logistics behind Zoom and how we can do this kind of more interactive thing. So Juliana stayed here in the main session, so she didn't get a chance to introduce herself yet to anyone. So I'm gonna say, hi Juliana, I'm passing it over to you. Tell us a little bit about what you do and your work here at Beyond Benign.
Hi everyone, nice to meet you all. I'm Juliana. I'm the communications intern for Beyond Benign. And I just want to let you know that if you guys have social media, we are there. We love to talk to you. So that's our Twitter and Facebook. And I also like to share that we have now a news page on our website. And we're basically gathering all the information, everything that our community is doing, all the amazing things you are doing, and just putting it in one place so we can have everything that's green chemistry related there. So, but we need your help. Oh yeah, but if you want to access that, you just go through our website, our page, and scroll down and you'll see the news. Or you can go to our web page and then go to the tab called news, and then you'll see this. And also, if you guys want to be in our news and want us to share all the things you've been doing on social media, we have a form, our spotlights and highlight form. It's very small, so it's basically with basic information that we need to promote things. But if you don't like forms, you can always reach out to us via messenger or send a message or an email, and we'd be more than happy to support you and share all the amazing things and in every way we can. So that's it.
Awesome. Thank you, Juliana.
Thank you.
Yes, so please, Juliana makes beautiful art out of the things that are being submitted. So if you've taken a look at our news site or our social media, it really is Juliana's work there. But she's amplifying the voice of green chemistry by sharing your work. You do not need to be within the green chemistry commitment, any of our programs. If you've got something interesting within the space, please reach out to us. You can even do it in the chat today with Juliana and share your news. All right. So thank you, Juliana, for that. And we're going to transition over now into short content talks. So the first one up today is Felicia Eckhorn. And so she's going to be talking about her upper level green chemistry course. And so I'm going to stop sharing so we can get Felicia's sharing screen going on your side. So Felicia, I'm going to turn it over to you for the screen as I read off for your bio. So we are thrilled to have Felicia Eckhorn, a professor of chemistry at Virginia Tech, with us here today. We were introduced to Felicia through her work at the American Chemical Society presentations that she's done in the past, but our recent work through Dow and integrating green chemistry into higher education. So we connected with Felicia again and asked her if she would give this talk. She has a BS from Missouri State University, a PhD from the University of California, Berkeley, and she was an NIH postdoc from Harvard Medical School. Her research concerns the stabilization of proteins with small molecules to investigate cell division and collagen structure. She has been a sole PI on 4 major NIH grants, 1 NSF grant, and multiple smaller grants. She participated in 2 major NIH biomedical training grants for underrepresented students, and she created a green chemistry course, which she's going to talk to you today about, for senior undergraduates at Virginia Tech in 2009, and her textbook, Green Chemistry Principles and Case Studies, was published in January of 2020. So with that, Felicia, I will turn it over to you to share your screen.
Okay, so I'll try to make this quick. I'm really excited to introduce the things that I've been working on, and really it's been, oh gosh, I think I miswrote it. It was 2007 when I started this course. And it's an upper level green chemistry course. And I don't specify really that it's not just for seniors, although seniors is mostly what I've had. There have been some juniors who have taken it. The only prerequisite is 2 semesters of organic, which implies 2 semesters of Gen Chem. And often students have had engineering, chemical engineering courses. I get a lot of chemical engineers at Virginia Tech because there's a green engineering minor. And my course from the beginning has counted in the green engineering minor. So I have a lot of engineers and people from all over campus, industrial design and biomedical systems engineering, all kinds of students, biochemistry. So it's been really great. The course has had as many as 28 students in it and as few as 8. And I prefer it to be around 15. That would be ideal. So I do a lot of interactive things. I have this present a paper from the current green chemistry literature. I pretty much specify 2 journals, Green Chemistry from the Royal Society and ACS Sustainable Chemistry and Engineering. We choose a paper together. I guide them, give them really detailed guidance on how to put together a PowerPoint, because I look at this course as kind of a capstone. It covers really all areas of chemistry, although it's definitely heavy on organic. I'm an organic chemist, but I also think our economy is heavy on organic chemistry. But we do cover batteries and paints and a lot of inorganic things as well. So I want to, my textbook really came from the course. And so they're intricately interconnected. Wait, I need to get into presentation mode and hopefully, okay. So the textbook and the course are based on the 12 principles of green chemistry. And in each chapter, there's 12 chapters, 12 principles. Each chapter has one sort of major case study that represents that principle primarily, but there's always a question at the end of each chapter. What other principles does this satisfy? And so there's a lot of going back and forth, and I try to introduce all 12 principles on day 1 and talk about what that really means. And some of these are really hard. For example, avoid derivatives. I changed this title to avoid protecting groups because students didn't know what derivatives were. I was getting all kinds of things. They were thinking math and engineering. So I try to guide them to that. But in addition, there are sort of minor case studies sprinkled throughout that illustrate different aspects of each of these principles. And I hope by giving a wide variety of case studies, it really helps integrate their understanding of the principles. And the case studies, the idea for using case studies came from Michael Kahn's books, Real World Cases in Green Chemistry. He's really my hero because I used his textbooks for something on the order of 10 years before I switched to using my own. Okay, so my course, it has a spiraling curriculum where concepts and ideas keep recurring as we progress through the course. So So the, for example, with catalysis in chapter 2, palladium is pretty much, undergraduates know palladium as a catalyst. Palladium catalyzed carbonylation is used in the 3-step synthesis of ibuprofen with high atom economy. The copper tempo stall created for oxidations is a little more complicated, but it's still metal-based. And then over here, I have some of the enzyme-based catalysts. So Eastman created an immobilized lipase for personal care, and it gets a little more complicated as we progress. Teshik Yoon at Wisconsin developed a ruthenium photocatalyst for 2+2 cycloadditions. This gets really complicated with multiple ligands. So it's starting to build on the ideas they've seen already. In chapter 7, there's an engineered bacteria that Genomatica developed for butanediol production. That's as a commodity chemical. And the bacteria is full of enzymes that catalyze each step in the process. So it's a multi-enzyme system and living bacteria. Chapter 9 is about catalysis. And so there's ruthenium metathesis, Grubbs catalyst, using fatty acids as a renewable feedstock. Codexis is really well known now for making evolved enzymes that improve the organic chemistry to make drugs. And sitagliptin is a really important diabetes drug. And then recently, a Japanese group developed or discovered a soil bacterium and found this enzyme called PETase that degrades polyethylene terephthalate. And then finally in chapter 11, real-time analysis, there's this complex protic, it's sort of a combination protic-Lewis acid catalyst that's very selective for terminal alkenes in producing polyisobutylene. So it just keeps getting more complicated, but I think it really reinforced the concept of catalysis. And this happens with a lot of the other concepts as well. So, and now okay. Throughout the book, I use mechanism, and each chapter has a mechanism question in the problem set for the chapter. So in the appendix, I give them a method for figuring out what the mechanism is. And I just use this convention of green as a leaving group, red as the electrophile, and blue as the nucleophile, hoping that by color coding, at least initially, they can identify the nucleophile and the electrophile in each step. And then it's the conventional, I firmly emphasize using all the lone pairs and getting the charges right and balanced, and then the curved arrow formalism mechanism. And this is what I expect of them. So this is outlined, but using biodiesel as the example to teach this. And it's a 10-step method for writing a mechanism. All of the areas of chemistry are represented, as I said. The first chapter has an organic example of polylactic acid. And the reason is because there's a life cycle assessment of NatureWorks PLA. And it's great to introduce life cycle analysis early in the book. And I'm not going to go into details about it, but that's the organic example. For inorganic, I have to introduce the idea of quantum dot light emitting diodes. And these are cadmium selenide particles. And what's really cool about this is that the size of the particle determines the color of the quantum dot. And this is the rainbow of colors that you can, with the actual quantum dots in vials. So this had been a really dirty process using these phosphine oxides as the solvent and this really difficult dry box purification. And QD Vision developed a greener method that they won a Presidential Green Chemistry Challenge Award with just a wax and octadecane as the solvent. And then they don't purify the core. They discovered that if they didn't purify it, they saved a lot of solvent. So this is a two-step, one pot reaction. And so this is a good example of not only inorganic chemistry, this is main group inorganic chemistry, but it's also nanoparticles. Okay, so just for physical, I have in the energy chapter a long discussion about thermodynamic versus kinetic control, which leads to specificity. And I think thinking about these things from a physical chemistry point of view is important. And then it also, physical chemistry comes into play using molecular orbital models when they're necessary. So for Tushik-Yoon's 2+2 cycloaddition, this is the explanation of the photopromotion of an electron and the 2+2 orbital symmetry diagram. And I think it's important to bring that in. We also use molecular orbitals to explain the aromaticity of imidazolium cation and why that contributes to it being the imidazoliums being good ionic liquids. And then for biochemistry, there's a number of cases where an enzyme is used as a catalyst for a chemical step. So this is the example of simvastatin, a cholesterol lowering drug. And no protecting groups were used, even though there are 3 secondary hydroxyls that could be acylated, and simvastatin needs it to be on only one, and they didn't have to use any protecting groups for the other ones. So it's really a remarkable thing. For polymer chemistry, I focus on biodegradable plastics as well as bio-resourced. So there's a discussion of how you could make propylene oxide from bioresources, but the stereochemistry makes it so that is actually more efficiently done with chemistry. And Jeff Coates introduced this 2-catalyst 1-pot synthesis of polyhydroxybutyrate, wonderful polymer that is biodegradable. For analytical chemistry, 3D Tracar created this system where they use a fluorescent dye to detect the buildup of microbes in the system, which can start clogging the coolant, and then they have to flush out the system and replace the water. So by having this in real-time analysis, they can eliminate the water changes. Well, not eliminate them, but make them much less frequent. So we discuss what is fluorescence with the Jablonski diagram and the various colors that the fluorescent dye undergoes. And finally, natural products, I use Taxol as an example of the source for the natural resource. I've gone way over time. So thank you for your patience. So I'm done.
Thank you, Felicia. That was great in terms of highlighting all of the things you cover in your course and how it progresses on and gets harder over time. So I am just going to share my screen quickly, but the next thing we do have on the agenda for today is just a quick little break. So we know in terms of like everyone's sitting on these Zoom calls for a while, so please do take a break. I am just going to update the time on here, because we are on schedule, which is great. So please do come back at 1 o'clock, and we're going to pick up at 1 o'clock with our next talk from Ed Bresch. So I will see you back here at 1. Go stretch those legs, grab a bite, all of those good things. It looks like we've got people back, so I'm going to transition into our next presentation. So I'm going to introduce next Ed Brush, and his talk is on the SDGs and racial equality in chemistry. Ed is a signer of the Green Chemistry Commitment. His department is. He's done an amazing amount of work in this space. I'll read his formal bio, but I can say that if you're interested in the SDGs, you're interested in social equality, justice, all of these things within the green chemistry or education space of chemistry, Ed is the person to talk to and is often looking for other people to talk with him. So Ed, as I kind of transition here, I'm going to transition things over to you. So feel free to start sharing your screen and I will read off your bio. So Ed Brush is a professor of chemistry at Bridgewater State University in Massachusetts, where he teaches organic chemistry and introduction to green chemistry. Ed is a co-PI on 2 curriculum projects at BSU to integrate and scaffold research and the UN Sustainable Development Goals through the BSU curriculum. He serves on the advisory board for the Green Chemistry Commitment and is a member of the ACS Committee on Environmental Improvement. He has contributed to the ACS CPT chemistry supplement and was a guest editor for the Journal of Chemical Education special issue on systems thinking and green and sustainable chemistry. Ed has co-organized numerous symposium and workshops on green chemistry and sustainable chemistry at national meetings. And I'm so excited to have Ed here today to share with you about his work. So Ed, with that, I'll hand it over to you.
Thank you so much, Natalie. And I just, it's really great just seeing everyone. And I really thank Beyond Benign for running these monthly forums to have these, to make these green chemistry connections and to continue them through the pandemic. It really is very helpful. Yeah, I'll be chatting a little bit about what we're doing at Bridgewater State University on the UN SDGs, and also just some thoughts that I hope will just start discussion about diversity, equity, and inclusion. I don't see myself at all as an expert on these, but what I do like to do is to bring people together and to bring in experts who actually really are well-versed in these areas and to learn from each other as we develop new curricula ideas and models that we can use for undergraduate education. This PowerPoint is in the Google Drive folder, and I've also put in some resources, including a green chemistry SDG matching exercise, the draft of a getting started document and bringing the SDGs into my organic chemistry class, and also my diversity, equity, and inclusion statement that I've included in my syllabus. So as Amy had said earlier, one of the great things again about the Green Chemistry Connection is that it's bringing folks together to have these discussions, and this really is a community of practice. And this is also exactly what I'm seeing at my institution, BSU, where I've been very pleasantly surprised by how the SDGs are being so quickly integrated into our curriculum. The idea has been very well received across the entire campus, and it's been taking off despite the pandemic. And what I hope to do is here continue these conversations and also to develop new partnerships with you all. So to start off, as other folks have said, we are looking at a paradigm change in chemistry education, which in my opinion, really rests on the UN SDGs, the world's to-do list, where the chemistry enterprise just has so much to contribute to identifying, understanding, and solving these issues. But this paradigm chain rests on a very solid foundation that we are also developing: green and sustainable chemistry, systems thinking, of course, to make those connections, innovative pedagogy, such as those we see in high impact practices like research and engaging our students. And then, most importantly now more than ever, but to have a curriculum that's designed for equity, engagement, as well as accessibility for all of our students. So I'm just going to outline the evolving BSU curriculum projects as I've said, there is broad engagement across our entire campus. All of our academic colleges have been involved. Also, that something that shouldn't be taken lightly. This has been 100% faculty driven. So bottom up, I guess. But our administration has been absolutely supportive about this, and 100%, even through the pandemic. Support from our administration for the STG projects has still been going very, very strongly. So this all started with a Kerr transformation grant to integrate and scaffold research through our curriculum. And this is now being done more broadly through the entire BSU curriculum. A internal academic innovation grant to bring the UN SDGs and high impact practices through the curriculum. These two projects have merged over the past year, where the best practices of each are now being used to drive these broader curriculum changes across campus. And then we had this wonderful announcement just last week when we started up that our colleagues in physics and psychology got a big NSF grant. I believe it's an IU's grant to look at how to form these linked course communities, which is actually what we're doing now through our SDG innovation grant, and that these linked learning communities are going to be based on high impact practices and also one or more of the UN SDGs. So to get that into an NSF grant, I just thought was the coolest thing I could imagine. Because NSF you don't usually think of as being very receptive to the SDGs, let alone green chemistry. So in outlining four-year curricula, whether it's at the department level or the broader institutional level, as we're trying to do with our core curriculum, we've been starting with some overarching or defining what the overarching guiding principles are, looking at what the learning outcomes may be for years 1 through 4, because we do want to scaffold this. That's very, very important. What works, what needs improvement, and then most importantly, looking at the innovative pedagogical approaches. And finally, doing this under the umbrella of an inclusive curriculum. So this has been the kind of framework that we've been following, or outline that we're following in doing all of these curricula innovations. And so far it's been working pretty well. And just to continue with some more specific projects in the chemistry department, we now have project-based learning in introductory chemistry and organic chemistry, where we're integrating and scaffolding the UN SDGs, green chemistry and systems thinking. Something that we're starting up this fall, project-based learning course collaborations. This is similar to that NSF grant, except this is going to be at a higher level. And basically what we're doing here is we're bringing faculty student research into our courses with a context that is being driven by the UN SDGs. And we're very excited about that. We have a group now that's forming, that's going to have a central topic based on human and environmental health. And obviously I'm all over that with green chemistry. And then something we're piloting this year, it's going to be a new part of our undergraduate research program, the UN SDG Scholars, that's going to be focused on students who are working class students or traditionally minoritized students who fall through the cracks about getting involved in our more formal undergraduate research program. And these students will be involved in virtual research. We actually learned we can do that and actually do it pretty effectively, or at least the mentoring part of that we can do very effectively. And they'll be engaged in research with a focus on the UN SDGs and mentoring. So we're piloting this not only at BSU, but at different institutions. If you'd like to learn more, please feel free to reach out to me. Again, the UN SDGs is the common thread that's linking all new curriculum innovations we're seeing on our campus right now. It's absolutely incredible. And BSU has been making some strong steps to talking about and acting about racial equity at BSU. Allowing people to listen and to be heard, respecting their opinions, becoming aware of our own inequalities, micro inequalities, and what we've been doing, understanding that self-reality, and then now we're starting to move into the transformation stage. We have a special presidential campus-wide task force on racial justice, We have our College of Science has a equity task force as well. We have a working group that's discussing how we can bring environmental racism and environmental justice into our classes, as well as student-led group discussions in our classes on diversity, equity, and inclusion. So that's what we've all got going on. As I said, despite the pandemic, we have a lot of these great initiatives that are just rolling full steam ahead. So thank you all. There's my contact information, and great folks I need to acknowledge Beyond Benign. Other folks that we all know, Jane Wissinger, Jenny McKellar, Grace Lasker from the University of Washington, and from the teams at BSU. And thank you to the Provost's office. And we hope to see you, at least virtually, at the ACS meeting in San Antonio, where we will be continuing these discussions. So thank you. That's it.
Awesome. Thank you, Ed. And I know, so to kind of follow that up, but we've had these short talks. The goal is to have breakout discussions. So that's what's coming up next. Before that, we are going to hear from Janie Butler, our K-12 program manager, just shortly. But I want to say, if you are interested in being in a breakout group, so either looking at the green chemistry principles and the course on green chemistry, or Ed's discussion on the UN SDGs and racial equality, please let me know which group you would like to be in the chat so I can set up the breakout rooms on the backside as we hear from Janie Butler. So I'm going to pull up my slides on this side. Get over to all right. Oop, and I'm advancing them. Here we go. So I'll just quickly introduce my colleague at Beyond Benign. Janie Butler works as the program manager in the K-12 space. And we're always kind of looking to each other to see what's going on in the K-12 space versus the higher ed space. How are they different? How are they the same? How are they interacting? And so I'll hand it over to Janie to tell you a little bit more.
Hi, everyone. My name is Janie Butler. Thank you so much for the introduction, Natalie. And thank you to all of you for giving me some time to speak. I'll try to keep it pretty short. But as Natalie mentioned, I work in the K-12 space. So she specializes in higher ed, and I work a lot with teachers. So elementary school teachers, middle school teachers, and high school teachers. We'll dive into that a little bit more of what that looks like, but Natalie highlighted it really well. We're trying to figure out, since there's such a powerhouse of higher ed educators and also of K-12 educators, where are these crossovers? Where can we intertwine a little bit more to take advantage of all these expertise and specialties we have in the field of green chemistry education? Maybe if we could go to the next slide. I don't know, my computer's a little lag, so I might be the last to know. I'm looking to Natalie.
Oh, do you see the theory of change there for Beyond Benign, Janie?
Oh, can you go back to the map?
Yes. How about now? Do we have a map?
Not for me yet, but I can talk to it. So in this map, you'll see that there's a whole bunch of green chemistry commitment signers. Hopefully you guys are familiar with the green chemistry commitment, and that is in green. You can see there's a whole bunch of them from all over the country. There's also some that are more international. For K-12, the way that we organize is we have a team of lead teachers. Right now, there are 12 of them from throughout the country. And these are teachers who specialize in green chemistry education. They have been practicing it within their classrooms, and they've been doing it for a series of years. So with us at Beyond Benign, they are signed on and they work with us for a total of 3 years in creating green chemistry resources, in leading green chemistry trainings, and in mentoring other teachers for how to implement green chemistry into more classrooms. We've also had some teachers who are up in Canada, and you can see on this map with the blue dots, the teachers who have either gone through the 3-year program or the teachers who are still within it. And I cannot say enough good things about these teachers. They are truly amazing. They are the heart and soul of this program. They are the ones who really get the work done. So I am just their spokesperson. They are all having a little bit of a hectic time jumping back into school. So a few of the teachers wanted to join us. They're not able to make it today, but they are really, really amazing. And I just work as a liaison of saying what they can do and how they can help further the mission more so. Okay, now I'm ready for the next slide, Natalie. I'm going to just start talking and think that it's up there. So our theory of change at Beyond Benign is that you can see at the center is that it can start at K-12. So if we have students who are learning more about K-12 education, they're starting to think about critically about chemistry, of maybe this could be done in a more sustainable way. Maybe we can use more green practices and learn about the term green chemistry. If they're able to learn that at high school or even middle school or elementary school, their mindset and their critical question asking and challenging of norms in the chemistry field is just going to percolate as they go further out into education. So you can see after K-12, we have higher ed. That's where a lot of you guys reside. And hopefully my goal would be having students saying, how can we do more green chemistry? How could this be done in a greener way? I really think that would be a huge sign of success. Afterwards, we have green chemistry innovation at the industry level. So hopefully through our collective work, we're able to have more industries creating things using green chemistry, that there's more jobs that utilize green chemistry that want these critical thinking processes, and we already see that happening. Another goal of this is that all students, not all of them are going to become chemists, but they're all going to become consumers. So if they're thinking about ingredient lists, if they're not afraid of the word chemicals, if they understand that chemicals are in everything we do and that it's important to see how to do those greener, then they're going to look at products in a different way. Maybe they won't get as tripped up when things say crazy things like chemical free. You know, they'll be able to think about what they're really looking for and what it truly means to be green and how to buy and support those industries opposed to other ones that are greenwashing. And overall, our whole goal is to change the world. We like to shoot large and have more sustainability for both the human health and the environment. So you can see along the bottom of this slide here, I think we would all agree to this, that we're trying to advance green chemistry for a sustainable future. And the only way we're able to do this is through a collective whole and as a community. Maybe we're on the next slide. Sorry, guys. Yeah.
Yeah, I moved quickly. So we're just saying that there's an intersection here between the two of them. We see that as community engagement. And so the next slide that we've got up here is about a presentation that was done at AACT this past summer. And so you'll see here there are lead teachers and higher education educators on here. And it highlighted the work that's been going on between these two groups. And so with that, I will kind of pass it back over to Janie, I hope, because she's going to be talking a little bit about what the lead teachers, and this was also presented a little bit at that AACT webinar, but what their plan is for the year to come. And so hopefully Janie sees her two lead teachers on the slide now to give you that information.
Just going blind. But Natalie made a really good point. This is something that we're starting to work a lot on, and we really want to see those crossovers. And so these are two teachers who's asked me to share out what they're doing in hopes that we can further their work more. They are amazing. I'll let them speak for themselves in a second, but they're both based in Michigan, Jen and Erica, and their goal is to work with more education departments at universities, colleges, and at the higher ed level. The work that they have been doing and that they want to do more of is working with pre-service teachers. So students who are studying education, who are hoping to work in the sciences or chemistry, there's a lack of education there in methods courses or understanding toxicology. They'll speak about this more, but they're offering to join into these methods courses free of charge, just to be guest speakers, to possibly lead some workshops, and it can be customized to the learning aims of those students, but just to provide resources and bring these students into the community of green chemistry educators, show them what we have to offer, and hopefully show them how things can be done using green chemistry. So the next slide is a video, which I think is a wild thing to try to do over Zoom. So I think we're all going to cross our fingers that the audio works well. I think it'll work best if we all put ourselves on mute, other than Natalie.
Yep, so I do have it queued up on this side, and so you are going to hear from those lead teachers on their pitch of why they're doing this.
Hello, fellow science teachers. My name is Jennifer Sherburne, and I'm here with Erica Patura. Together, we have over 30 years of experience teaching science in 2 rural West Michigan public schools. It's taken us years to learn proper lab safety, and we're hoping to better equip the next generation of teachers with the tools and labs to start off with safe science.
We are also lead teachers with Beyond Benign, a nonprofit organization focused on green chemistry education and sustainability. Our passion for science and doing highly engaging science in a safer way has led us to realize we need more conscious effort and awareness.
When science teachers take on their own classrooms and storage rooms or stock rooms, they assume responsibility and liability to teach a curriculum that is both meaningful and safe. In our research, it doesn't appear that this is done with a consistent standard from district to district or even state to state. In this graph, a handful of conscious science educators from across the country report out the inconsistencies in safety training requirements for their district. And about 75% of these teachers report they either do not know if there's a safety certification requirement or report that there's not even a requirement.
Eckhart Tolle said it best when he said awareness is the greatest agent for change. With a conscious effort, we can do things just a little differently and safer for us, our students, and the environment. For example, instead of performing the terribly dangerous flame test demonstration using methanol, teachers could easily use colored birthday candles as a replacement demo.
In our presentation, you can expect that we will discuss and demonstrate these learning targets. First, understanding the importance of lab safety. Second, practicing replacement labs. Also, gaining access to safety resources. And understanding green chemistry principles and how activities can be greenified.
We hope to share stories and resources with your pre-service teachers through a 60 to 90-minute one-time workshop. Please reach out if this is something that interests you. Thank you.
Hello, fellow science teachers.
Thanks so much for sharing that, Natalie. I hope you guys appreciated it, and thank you for taking the time to listen in. If you are interested in doing this or connecting them with, if you have an education department or someone you think would also want to know more, you all have Natalie's email. I think that's the easiest way. On these slides, there's also the information for Jen and Erica. I'll put my email as well in the chat if anyone wants to connect further and gain more information about this. But this is just one of the many things that's being done to cross over K-12 and higher ed. I think it's a really exciting one. So thanks for listening in on this opportunity.
Awesome. Thank you, and thank your amazing lead teachers for offering up this opportunity. If you're interested, you can tell me in the chat, you can send me an email. That short little video was really to give you their kind of pitch behind why they're doing what they're doing, but also to be able to share out, right? If you have somebody that's interested, we can share that video with them in the future. Okay. So I do have, if you've told me where you'd like to go for a breakout room on the back side, I do have those set up. If you have not yet told me where you'd like to go, the options are Green Chemistry Principles with Felicia Eckhorn from Virginia Tech, or we have the UN SDGs and racial equality with Ed Brush from Bridgewater State. I will also offer up the opportunity, if you're interested in K through 12, Janie could talk to you as well. If you'd like more information, she's also just put her email into the chat as well. So if you told me what breakout room that you would like to go to, you are going to go there now. So I will open the breakout room so you will get a message, and I will call you back when we're getting close to the hour, but please have a great discussion. If you haven't told me yet, let me know in the chat. So we're just here to wrap up together our time together here today and talk about what is next. So I will just say, if anybody wants to kind of give their what you got from the breakout room, interesting thing you learned, anything, feel free to, you can unmute yourself, put things in the chat. At this point, it would be great to hear. I know we had a great discussion in the green chemistry principles one. I think we covered a lot in our time together. So I don't know if anybody wants to unmute from the other group and tell us a little bit about what you covered.
I'm gonna leave it if Ed wants to jump in here. But I'm happy to, there was such a great conversation that I think Ed got cut off like mid sentence as we got pulled back. A really great, some really great ideas that were shared in ours. And Ed, I don't know if you want to jump in there or not. It looks like, I think you're rejoined.
Yeah, I'm here.
Just, oh, you are, okay.
Yeah, I think there's interest first off in how do we bring conversations of diversity, equity, inclusion into our classes, and I mean, my personal response for that is to take it slow, make sure that you understand that, understand that first, understand what you want to bring to your students and how to best connect with them. And the other conversation that we were working on was how to bring questions of how to bring conversations to your community, depending on what that community is, whether it's related to issues of diversity, equity, inclusion, or if it's related to issues of chemical exposure. And where I got cut off there, I was going to say, make sure you know what your goal is, because it can very, very quickly de-evolve into a conversation of chemicals are bad and chemistry is bad. Focusing on just the unintended consequences instead of what green and sustainable chemistry can help bring to the conversation. Oh, and I am putting another article into the Google, just the Google resource sharing about how Worcester Polytech Institute is bringing issues of diversity, equity, inclusion into their courses, or at least a recommendation on how to do that.
Awesome, amazing, Ed. And I know that Ed mentioned during his talk a few resources also that he shared in this realm as well. And I know as well that Felicia Eckhorn had posted her book as a resource as well in the past, but in those shared folders, you have resources that have already been shared and mentioned here, but also the opportunity to share your own resources and connect with the community here. So I will just say, thank you all for joining us today. We're going to continue doing this. We absolutely love having you here. We want to hear your feedback. We want to make these even better for you, for the community, to keep this conversation going. So please don't hold back your opinion. We want to hear it, and we hope that you will join us for the next one. I am going to put a few things into the chat box here, so I'm just going to stop sharing my screen so I can do that. One is just that please, if you want to connect with those that you've met today outside of this space, please add your contact information into the contact sheet in that Google shared folder space. And then if you are interested in, or you are from a department and you have information about general inorganic chemistry laboratories, please fill out that survey. And then the last thing is to say, let us know what you think about our green chemistry connections. So give us some feedback either through that form or to us directly. And we hope you all are well. We hope your semesters are going great. We are sending you all the best, and please let us know how we could support you during this unprecedented semester. But we are so thrilled to hear of the inventive ways that all of the faculty we interact with are still bringing green chemistry to their courses even during this time. So I'll just hand it over to Amy if you want to say any final words as we close out, or maybe take your picture magic on your side. We will.
Oh, I already did. Oops, I already did in one of our breakouts, so you'll have to look for that tweet. I think it sums up our COVID work home environments. But thank you all. Thank you all for joining. We're really, really wonderful to see your faces and hear your voices and to hear all about your great work. So thank you so much.
Bye, everyone.